All right, u sub again. So now we have something like tangent. Can you rewrite tangent in terms of sine and cosine for me? What is it? Over cosine of x dx. Now, based on your u sub hints from yesterday, where do you look to call something u? So we are going to look here. So now we're going to say our u is equal to cosine of x. What is our du equal to? Sine of x. What kind of sine of x? Negative sine of x dx, right? Do we have almost that? What are we missing? The negative? So do we get negative du equals sine of sine of x dx? So this becomes negative sine of x dx. Means that becomes negative du. Sorry, negative du, and this is u. So what does this become? It becomes the integral of 1 over u du. Put the negative out in front. What's the integral of 1 over u du? ln. So it's a negative ln, absolute value of what? U? What was u? Cosine of x plus c. Oh, was that just amazing? Now you can integrate tangent. You know how before all you could integrate were the ones that were a derivative? Tangent of x is nobody's derivative, but can I write it as sine as cosines? And then do u sub. Guess what else you can do? You can do cotangent, because is it going to work the same way? Yes. You're going to work cotangent on your own. I'm not going to do that one for you. Now, if you don't want to do this every time, can you memorize the formula? Of course you can. But I want you to see how with many things you can use u sub and you don't have to memorize a bunch of stuff. So what you're going to memorize is you're going to memorize the integral of tangent of x dx equals negative natural log absolute value of cosine of x plus c. Now, what if I have something in there besides x? Then it's the integral of tangent of u du is equal to negative natural log absolute value of cosine of u plus c. If you are starting from scratch and not memorizing the formula, it's a double substitution. You're going to substitute for the tangent and you're going to substitute for the stuff inside. Otherwise, you just memorize the formula, you pick it, and you go through and do a u sub on just the angle, just this part. Got it? So you choose, but you need to, if you're not going to do anything else, oops, that was a boo-boo. Hang on, I can un-boo-boo. You're going to memorize this, or you're going to know how to get there. Isn't it amazing what we can do? So for cotangent, if you want to do it, I'm going to leave that as an exercise for you. Can you do the same u sub? Only, what's cotangent equal to? Cosine over sine. I should turn this on. Cosine over sine. But if we're just looking at the formulas to memorize, it's the integral of cotangent of u, right? du is equal to natural log absolute value sine of u plus c. And you're going to memorize that one. What do I want you to do? I want you, on your own, when I finish with notes, I want you to do integral of cotangent of x dx. What does cotangent equal? You just told me. It's integral of cosine of x over sine of x. What are you going to pick? Sorry, x. What are you going to pick as your u? Sine of x, and then I want you to do the u sub on it to see that you're going to get that formula with the x's. That's what you're going to do on your own in a minute. Got it? Okay. So what are the only other two trig functions we haven't figured out? We know secant x, secant x, cotangent x, and we know cosecant x, cotangent x. But what about secant x and cosecant x? We don't know how to integrate those, do we? All right. So these are ones you're going to memorize. I could show you a trick, but the problem is the trick is as complicated to memorize as the formula. Why don't we just memorize the formula? Got it? There's an algebra trick you can do, but it's not intuitive, and it's kind of long and complicated, and this one you just need to memorize. It's a very similar pattern to pst, but a slight variation. Remember derivatives? Pst. Okay, this one that you're going to memorize is the integral of secant of u du, where u is that angle, is equal to, it's a natural log, just like all of these, the ones that are not a derivative. When I integrate the tangent functions that are not a derivative, that's tangent, cotangent, secant, cosecant. Those aren't somebody's derivative. Remember? From pst. So they're all natural logs. This is the absolute value, but instead of being like secant x, tangent x, it's secant u plus tangent u. Instead of multiplied, plus c. And the integral of cosecant of u du is equal to the natural log, but it's a negative, right? Starts with a c, it's negative. Absolute value of cosecant of u plus cotangent of u plus c. Do they look very similar? Are they similar to the derivative, only I got a plus instead of a multiplication? And it has to do with, remember the, anyway, don't worry about it. There's a trick to it, but it's not worth it. Just memorize the formula. So this is definitely a memorize. You don't have a choice on this. I'm not showing you the trick. It might be in our book. But it's something that you would have to memorize the trick. And why memorize the trick when you can memorize the formula? Oh, look at all the things y'all know now. Isn't that amazing? Yeah. Okay, I'm going to give you more hints. More hints. On the more hints, the very first one, most important, I'm going to even write it on red. If you have natural log of g of x, natural log of anything, you're going to pick the natural log of g of x equal to u. Every single time. If you see a natural log, you don't know how to integrate natural log. You don't learn to integrate natural log until second semester calculus using integration by parts, a technique that is not in AB calculus. So the only thing you can do is and even then, when you learn the technique, you're still going to pick natural log as your u, even in that technique. It's just a more complicated, that thing, that elvish weird stuff I put up to show you what BC was doing. Natural log is always u. Doesn't matter if it has something inside. Always, 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 always pick it as your u. You see natural log, it's u.
So you're going to find du.
You take its derivative.
Oh, yeah.
Yeah. Which is going to be, if you take the derivative of this, the derivative with respect to x of natural log of g of x is equal to g prime of x over g of x, right? So it's something you can, and then if you have something of that form, is that going to be easy to integrate? I mean, right? Yeah. So that's always going to be your u. Every single flipping time. Got it? And it's going to reappear. You'll see what I'm talking about. All right. Remember, these are other hints. Next hint, if you have the square root of stuff, that's stuff to the half power. We like that. That means it's power rule, right? If it's cube root, it's the third power. Cube root of stuff, which is my u, is equal to stuff to the 1/3 power. Repeating that, because y'all forget that. If we have stuff in the denominator, is it a negative power? Third hint. We talked about it yesterday. I'm really, what I see is y'all forgetting that y'all can do this. Sorry. Just because it's in the denominator does not mean it's natural log. If it's raised to a power, you can write as a negative power and is it power rule. Oh, please remember, negative 5 plus 1 is not negative 6. I'm not joking. Negative 5 plus 1 is negative 4. And then don't mix up taking a derivative with integrating, adding 1 or subtracting 1. Y'all mix that up a lot. So now what I want you to do is you have a worksheet. Right? Did I put the worksheet at the door? Oh, I didn't. Whoopsies. Okay, I'm going to pause. We are recording again. So you're looking at the match worksheet. We're looking at match. At the top, it has the integral of 1 over u du. Put an equal sign. You see it at the top of your paper on the match. What is the integral of 1 over u du? Natural log absolute value of u plus c. Everybody got it? So down there, anywhere on this worksheet where you have 1 over stuff, you're going to pick stuff as your u. You're going to end up integrating 1 over u du. So this is the pattern. So is this A? Do they call this A on this one? That one? So this is A. So on that worksheet, whenever there's a little blank there, what form is it? It's A. You're going to pick A, right? This is to help you identify patterns. Okay, then there's B. Now what does B look like? It is the integral of u to some power n du. If this is power rule, stuff to the n power. What's the new power? So it's n plus 1 over n plus 1 plus c. So if you see a pattern where it's some stuff raised to a power, can it be a fractional power? Yes. It can be a half, it can be negative a half, it can be 5, it can be negative 5. Anything like that. Is that going to be power rule? Are you looking for that pattern? And then the last pattern you're going to see on this worksheet, because there are more, it's e to the u du. If you see an exponential function raised to a function like stuff, then every single time it's going to just be e to the u du, because you're going to do the whole derivative thing for u and du, and the derivative of stuff is going to be multiplied times to the e to the u. You'll see what I'm talking about. I promise you will. So those are the 3 patterns you're looking for. Every single problem on this front page is either of the form A, B, or C. It's a natural log, it's a power rule, or it's an exponential. Everybody look at number 4. For your number 4, what was it? What did they give you? The integral of natural log of x, right? Over 2x dx. So looking at that, what did I tell you every single flipping time is u? Is that going to be u? So u equals natural log of x. All right, do you notice that you do not have room to work on here? You don't. So on a piece of paper, you're going to show all your work that goes with this, because there's not enough room for you to scribble all over this. There's just enough room on here for you to pick you and do, you have enough room to do this on there and pick a pattern. To actually integrate it, you need to go to another piece of paper. Yes, you should. Okay, what is the derivative of natural log of x? Well, so 1 over x, because the derivative of x is 1, dx. Do I almost have this? Let's rewrite this thing. Can we pull that 2 out and make it a half? Do we agree that dividing by 2 is the same as multiplying by a half? So do we have a coefficient of 2? Integral, and then this is natural log of x times, if that's in the denominator, is it times 1 over x dx? Hang on, let me do something for a second. Let me lasso this and move it. Move this over. It's a lasso. And then this is 1 over x dx. Does that mean the same thing? You need to be able to look at this and realize that's a coefficient, that's 1 over x, and then if I do that, is this exactly du? And this is u. Wow. So this becomes 1/2 integral of u du. Is that the easiest thing to integrate on the face of the earth? Is that what u sub is for? You take something complicated where you have a hard time seeing the pattern, and if you follow the hints I give you for u, does it boil down to something that's easy to integrate? We go back to the very first section when we first started integrating things and going backwards, and it's that simple. Is this just power rule? Because is this a power of 1? Right? So what is the integral of u du? What's it equal? So I got 1/2 u squared, but we'll put the u back in a minute. Divided by what? Divided by 2 plus c. So if I substitute back in, because you can't stop at u, is it going to be u, so it's natural log of x, that's my u, over 4, because it's 2 times 2 plus c, and I am done. Oh yeah, I'm going to square it. Thank you. I just forgot to write it. And that's y, right? When we integrate something, is that the y? You just solved a differential equation. Isn't that awesome? So so what pattern was this originally? This was an A, because I saw the natural log. So can you go through every single one of these and find all the A's? All the ones with natural log, are they going to kind of fall out? Yes? They are. They're going to fall out. I want to do another one, and can I borrow your worksheet for a second so I can find out whatever it is? Okay. Everybody look, you're looking for x e to the 3x. Do I have it on here? Am I just making one up? I may have just made one up. I have been known to do that. Huh? 13? No, that's different. Okay, I'm making one up. I'm going to show you how this works. So, if we have an equation, what if I give you that I want you to integrate x e to the 3x squared dx? Okay, it looks exponential, doesn't it? So it's probably pattern C. Probably. So what is that? If it's pattern C, what are you going to pick as your u? I'm showing you how you're going to work through these when you're not sure what to do. This is going to be u, right? So u is equal to 3x squared. What's du equal? 6x dx. Look over here. Do we have the x and the dx? We don't have the 6. Can we get rid of that? Does this become 1/6 du equals x dx? So when I do my substitution, this is going to become u. Or I already did that one. That's u. So I could rewrite. Let me rewrite this. This is equal to the integral of e to the 3x times x dx. That make it easier? That means this is u, and this is 1/6 du. Do y'all see that? So what is this going to equal? Hang on. Didn't do that. Y equals. So I'm going to integrate e to the u. I'm going to take out the x dx and I'm going to put in 1/6 du. Do I pull the 6 out in front? It's just a coefficient. 1/6. What is the integral of e to the u du? Did I just take something complicated and make it look really simple? That is the whole point of this method. And is it just a change on the coefficient? Did everybody see that? So what is the integral of 1/6 e to the u? 1/6 e, what was my u? 3x squared plus c.
Más simple.
See? Huh? What's the huh for? Why huh? No huh? All right, guess what y'all are doing?